So our next speaker this morning is Professor Emeritus Peter Sikkema. Peter recently retired after 36 years at the University of Guelph Ridgetown campus, where he focused on weed management in field crops. Peter taught several courses including applied weed science and herbicide biochemistry and psychology. Peter published more than 445 peer-reviewed manuscripts. Peter is a source of practical solutions for farmers and readily shares his knowledge with primary producers. Peter has presented the results from his research programs at hundreds of grower meetings and scientific conferences across Canada, the United States, and globally.
Well, thank you very much. In my presentation this morning, what I'd like to do is I'd like to address the question, why do registered herbicides provide variable weed control? And before I address that question specifically, I'll just share some opening thoughts with you. I think that herbicides are incredibly valuable weed management tools, but because they're impacted by plant physiology, weather, as well as soil characteristics, weed control is variable. Frequently, the reason for less than acceptable weed control with herbicides is outside of everyone's control. However, sometimes it is human error. I will go on to say that I think it's irresponsible for herbicide manufacturers, ag retailers, agronomists who guarantee perfect weed control with herbicides. And I will also say that I think it's unreasonable for farmers to expect perfect weed control with herbicides in every field every year. So just to illustrate my point, this happens to be multiple herbicide-resistant Canada fleabane in Ontario. You'll see that this is Walt McLean's farm. He farms near Harrow, Ontario. And I think that if I recommended Roundup plus Aragon plus Merge to Walt McLean, I might be on his Christmas list next year. That's pretty impressive weed control. What's really interesting to me, though, is this happens to be Mike Smith's farm. He farms less than 100 kilometers away from where Walt McLean does. The exact same herbicide was applied, Roundup plus Aragon plus Merge. It was applied at the same growth stage of the Canada fleabane. We target 10 centimeter or 4-inch weeds at the time of application. The same research technician applied the herbicide treatments using the same sprayer, same water carrier volume, same spray pressure, and same nozzle tips. And you can see that I think Mike Smith would be really disappointed if I made the exact same recommendation to him as I did to Walt McLean. So I went through our database. We had 93 trials over about a 15-year period where Roundup plus Aragon plus Merge was applied. And you can see that in 58% of the experiments, the control was between 90 and 100%. In 9% of the experiments, it was between 80 and 89%. In 9% of the experiments, it was between 70 and 79. In 8%, it was between 50 and 69%. And in 16 experiments, where in 5 experiments, this treatment provided 100% control. In 16%, it was less than 50% control. And in the most poorest control, we got 6% with the exact same herbicide treatment. And so the question is, why? And that's the question that I plan to address in my presentation this morning. So variable weed control with herbicides may be due to extremes in weather, variations in soil characteristics, weed specifics, the incorrect application timing, application issues, or you simply chose the wrong herbicide for the weed spectrum in that specific field. So in terms of extremes in weather, there's 2 things I will cover. First of all, too little rain after the application of a soil-applied herbicide, and too hot and dry at the time of the post-emergence herbicide. So in terms of too little rain after the application of a soil-applied herbicide, if you choose to spend money on a soil-applied herbicide, you are counting on rainfall to dissolve that herbicide into soil water solution. And as the developing weed seedling takes up moisture to support growth, you as a grower hope that it takes up a lethal amount of herbicide and you get perfect weed control on your farm. And this is referred to as herbicide activation. And if no rainfall occurs within 7 to 10 days, weed control may be reduced with almost all soil-applied herbicides. This happens to be one of my experiments. It is at the Huron Research Station. And here we're looking at Frontier for green foxtail control in dry beans. And you can see the really disappointing control of the green foxtail with Frontier. I think Frontier is an excellent herbicide for the control of green foxtail. However, in a dry year, this is what would happen. And very similarly, this is lamb's quarters control with Clisto. This happens to be at Ridgetown campus. And once again, the year that we did that experiment, we didn't get an activating rain, and the control was really disappointing. So there's numerous studies in the peer-reviewed literature to support what I just said. This happens to be research that was conducted by Yamei et al. In 2016. And where they got greater than 12.5 millimeters of rain in the 7 days after application, more than half an inch, you can see the control was 88%. However, where the rainfall was less than a quarter inch, you can see that the control was reduced to 62%, or there was a 26% reduction in control because they didn't get an activating rain event after application. In terms of too little rain after the application of a soil-applied herbicide, with some herbicides, not too many, rain is required to move the herbicide into the soil to protect the herbicide from photodegradation and volatilization losses. So some herbicides will just turn into a gas and they will volatilize off, or they're broken down by sunlight if they remain on the soil surface. And you have reduced weed control under dry conditions with the group 3 herbicides like Prowl. And here you can see disappointing giant foxtail control with Prowl. And presumably we didn't get an activating rain event. The herbicide remained on the soil surface. It was broken down by sunlight, and a portion of it was lost due to volatilization. And this is some research to support that. It was done by a graduate student while she was in my program, Andrea Smith. And she looked at both large crabgrass and barnyard grass control with Prowl, where the sites that received 4 to 8 tenths of an inch of rain in the 7 days after application, the control was really good at 93 and 97%. Really interesting, where there was less than 4 tenths of an inch of rain, you'll notice that there was a 14% reduction in crabgrass control and a 22% reduction in barnyard grass control with Prowl. I do want to stress that these results are confounded by soil characteristics as well as weed density. Andrea did this research on 5 different farms in Ontario over a 2-year period. So obviously there was different soils on these 5 farms, and we had different weather conditions as well as weed density, and all of those things would influence weed control. So the question is how much rain do you need to activate a soil-applied herbicide? So I attend the Tuesday Ag Breakfast meetings in Ontario. One week it's at Ridgetown campus, the next week it's near Exeter, Ontario. And it's just 20 to 40 people that get together for breakfast, and there's one thing on the agenda. every time we meet, and that is, what did you see in the field the last 2 weeks? And in a dry year, generally speaking, I'm the only weed scientist at those ag breakfast meetings. In a dry year, somebody is guaranteed to raise their hand. They'll look at me and they'll say, Peter, how much rain do we need to activate a soil-applied herbicide? And I give them this really unsatisfactory government answer, right? And I say, it depends. And I'm sticking with my government answer. I think the number one thing that influences how much rain you need to activate a soil-applied herbicide is the soil moisture conditions at the time of application. If your soil is almost at field capacity, the day that you put on your soil-applied herbicide, you may get a 1/4 inch of rain, and that's enough to activate that herbicide. In contrast to that, if your soil is powder dry, the day that you put on your soil-applied herbicide, you could get 1 inch of rainfall, and it may not be enough to activate that herbicide. The amount of rain you need is influenced by soil texture and organic matter. You would need more rain on a heavy textured soil that's high in organic matter than a sandy soil that's low in organic matter. I'm convinced that the amount of rain you need is influenced by the herbicide group as well as the active ingredient. And I think that the Group 15 herbicides are the first to fail in a dry year. Herbicides like Dual Frontier as well as Zidua. I think it's influenced by the herbicide rate that you apply. So if you can weatherproof your herbicide to a degree by applying the high rate on the label, and it's influenced by the weed species. The first weed to fail in a dry year, or the first weed, I should say, to escape in a dry year, is going to be the weed that herbicide struggles on. The weed species that it's really good on, even in a dry year, you could get acceptable control. So now I'll move on to too hot and dry with post-emergence herbicides. During periods of drought, it's more difficult for post-emergence herbicides to cross the cuticle and enter the living portion of the leaf. And the cuticle is thicker and more continuous under dry conditions. In addition, lower relative humidity under hot, dry conditions reduces cuticle hydration, so it's harder for the herbicide to cross the cuticle and get into the living portion of the plant, and it increases the speed of drying of spray droplets on the leaf. Always remember that the herbicide gets into the leaf dissolved in water. If that water evaporates off and you have a crystal on the leaf surface, it's not going to get into the plant and you won't get weed control. And the above results in reduced herbicide absorption, and you have reduced weed control with almost all post-emergence herbicides. So this happens to be some research that was published by Waldecker and Weiss from University of Minnesota. And they looked under adequate moisture. 44% of applied glyphosate was absorbed by common milkweed. And notice under drought conditions that decreased to 29%. So there was a 15% decrease in the absorption of glyphosate under dry conditions. They went on to look at the amount of herbicide that was absorbed, what percent was translocated in the plant. And with adequate moisture, you can see that 20% was translocated. And under dry conditions, that was reduced to 7%, or there was a 13% reduction in the amount of glyphosate that was translocated in the plant. This is research that was conducted by Cal Messersmith at North Dakota State University. He was looking at velvet leaf control with glyphosate. Under adequate moisture, glyphosate provided 95% control, and under drought conditions, that was reduced by 35% to 60% control. Weed control is also influenced by variations in soil characteristics. It's influenced by, or you have reduced weed control on, on fine textured soils that are high in organic matter, and it's influenced by soil pH as well as by soil tilth. So most soil applied herbicides are adsorbed to clay and organic matter. And if a herbicide is adsorbed to the soil, it is biologically unavailable for weed control. And so the herbicide rate should be adjusted depending on soil type as well as organic matter. And many herbicides have restrictions on the label in respect to soil texture and organic matter. On the broad strike label, it says do not apply to soils with greater than 5% organic matter. Broad strike is used for broadleaf weed control in both corn and soybean. I grew up on a dairy and hog farm in Ontario. My brother and nephew still farm there. Every single field on their dairy farm has greater than 5% organic matter. So if my brother and nephew were to follow the label, they cannot use broad strike for weed control on their farm. The authority in Zidua label says do not apply to soils with greater than 6% organic matter, and the Treflan label says do not apply to soil with greater than 10% organic matter. Just to show you some data to support that, this is the impact of soil texture on weed control with authority. And so they were looking at velvet leaf control on a coarse textured soil. You think that the herbicide is available. It's in soil water solution, and they had 87% control of velvet leaf. Notice the decrease in control where they had a medium textured soil. There was a 7% decrease in control. And here you can see that there was a 29% decrease in control with the exact same herbicide applied at the same rate on the same weed species. And that's the impact of soil characteristics on herbicide performance. So there is poor weed control on fine textured soils. And on fine textured soils, a greater amount of the herbicide is adsorbed to the soil, and it's biologically unavailable for weed control. In terms of soil pH, some soil applied herbicides, soil pH affects the ionization properties, and some herbicides protonate and deprotonate depending on soil pH. So I'm guessing that many of you have forgot your grade 12 chemistry course. So if a herbicide protonates, it simply means that it accepts a proton, and the herbicide goes from a negatively charged herbicide to either a neutral or a positively charged herbicide. That's all we're talking about. So as soil pH goes down, the pH scale is the negative log of the hydrogen concentration in a solution, and the lower the pH, the more hydrogen atoms that can bind to the herbicide. Once that proton binds to the herbicide, it has a positive charge. Soil has a negative charge. They complex, and you have reduced weed control on low pH soils with some herbicides. And here you can see the protonation and deprotonation of a really common herbicide, 2,4-D. And the best example that we have in Ontario is at low soil pH, Sencor forms cations in the soil, which are more tightly adsorbed to the negatively charged soil, resulting in reduced weed control. This is a really interesting study. It was conducted by Brian Jinks and George Kagodi at North Dakota State University. They were looking at biennial wormwood control with broad strike. Really interesting to me, where the soil pH was 7.8, you can see that they had 100% control of biennial wormwood. Where the soil pH was 6.5, there was a 15% decrease in biennial wormwood control. And where the soil pH was 5.4, there was a 55% decrease in the control. And presumably at the low pH soil, more hydrogen atoms in the soil, It complexes with the herbicide. It now has a positive charge. It's bound to the soil and biologically unavailable for weed control. In terms of soil tilth, large clods may result in reduced weed control. Clods can prevent even herbicide application, and weeds can germinate and emerge from below those clods. And if there are too many large clods in the field, it should be tilled prior to herbicide application. So now I'll look at weed specifics, and I'll specifically look at cuticle composition, weed density, time of germination and emergence, as well as herbicide resistance. In terms of differences in cuticle, the cuticle varies in composition and thickness among weed species and during the growing season. Generally, younger plants have thinner and less developed cuticles, and thinner cuticles are more permeable to herbicide, which results in greater herbicide absorption and therefore improved weed control efficacy with almost all post-emergence herbicides. So this is some fascinating research by a whole series of weed scientists, as you can see here. And they were looking at the amount of epicuticular wax on these various weed species in micrograms per square centimeter. I had no idea until I read this research that there's a 28-fold difference in the amount of epicuticular wax in a lamb's quarters plant compared to a velvet leaf plant. One weed that Ontario farmers struggle with in terms of escapes in soybean is lamb's quarters. And probably one of the reasons why it is so difficult to control with post-herbicides is that it has just so much more epicuticular wax than the other weed species presented on the screen at the front of the room. The next thing that will influence herbicide performance is weed density. This happens to be research that was conducted by Christian Wilms while he was a graduate student in my program. And he was looking at water hemp control with Prime Extra. And where there are less than 70 plants per square meter, Prime Extra provided 98% control. And really interesting, I got ahead of myself, so if you have 98% control, that would be 1 weed escape per square meter. I think that's still unacceptable for most farmers. They won't accept 1 escape per square meter, but it's still pretty good weed control. Really interesting, where the weed density was greater than 700 plants per square meter, the control decreased from 98 to 79%. So there was a 19% decrease in weed control just based on weed density. And now you have 147 escapes per square meter, and that for sure is not commercially acceptable. Exactly what I said about Andrea Smith's work earlier. I want to stress that these results are confounded by rainfall soil characteristics as well as the water hemp biotype. Christian did this research on different farms in Ontario, so there's lots of things going on, but he could associate the performance of the herbicide based on weed density. And that's been well accepted in weed science. In this manuscript published in 1978, the authors said, "In fields with extremely heavy weed pressure, control may not be commercially acceptable." I think they're absolutely right. And some of the herbicide manufacturers have a statement on the label that says to increase the rate if you have heavy weed pressure on your farm. On the dual label, it says use the higher rate for heavier weed populations. On the atrazine label, it says use higher rate for heavy weed infestations. And on the Shieldex label, it says use of the higher rate for heavier weed infestations is recommended. I think all of those labels are correct. I think every herbicide label should have a statement on the label indicating that herbicide efficacy is influenced by weed density. Every farmer in this room knows that. If you talk to a farmer and if he was going to use a below label rate, would he use it on his field that has the heaviest weed pressure on his farm? None of them would, right? If you're planning to use a below label rate, you're going to use it in the field with the lowest weed pressure. Farmers know that herbicide efficacy is influenced by weed density. And I'm repeating what I said earlier. I think every label should have a statement on the label saying that herbicide efficacy is influenced by weed density. Weed control is going to be influenced by time of germination and emergence. Some weed species germinate late in the spring or early summer, or they germinate over an extended period of time. This is some really labor-intensive research that a previous graduate student of mine did. His name's Mike Shriver. And what we asked Mike to do is we asked Mike to go to a farm in Ontario and count how many water hemp plants came up in the previous 7 days. He would count them. This was in a non-cropped area. He would spray it with Liberty, burn off any emerged water hemp, and he would come back the following Monday and count how many came up in the previous 7 days. Make sure you note that this is a logarithmic scale. So in the 7 days prior to June 1, about 400 water hemp plants came up per square meter. In the 7 days prior to June 7, it was about 300. In the 7 days prior to June 14, it was about 500. What's absolutely amazing to me, presumably we got a rain event prior to August 22nd. There were still 100 plants that came up per square meter on August 27, and water hemp is still coming up on October 25. If you have a weed on your farm with an emergence pattern like that, that's going to influence your weed management program, and you're going to have to use a herbicide program that has really long residual activity in the soil to control those late emerging cohorts. So what you need to realize is that herbicide concentration is reduced due to photochemical and microbial degradation beginning immediately after application. So if you put on a soil-applied herbicide on Monday morning, you have less herbicide in your field on Tuesday morning because as soon as it hits the soil, it starts to be broken down by photochemical and microbial degradation. And if you have a late emerging weed, so let's say it comes up 4 or 6 weeks after herbicide application, there's just less herbicide in the field, and you're going to get reduced control. So you have reduced control of late emerging weeds such as water hemp and velvet leaf with a dicamba-based herbicide like Ingenia or Extendamax, or you have poor control of late emerging nightshade or fall panicum with group 15 herbicides. So I got these two pictures from Dr. Joe Eichele from North Dakota State University. I think they're just fascinating pictures. So apparently this water hemp plant, he took note of it. It emerged on September 1. And by September 25, that plant had grown vegetatively. It moved to reproductive growth, and there was viable seed 3.5 weeks after this water hemp plant emerged. So weeds sense their environment. They sense that there's declining day length. It goes from vegetative growth to reproductive growth, and it produces viable seed within 3.5 weeks of emerging from the soil. So in terms of single versus multiple resistance, this is Canada fleabane. This happens to be Tom Hebblethwaite's farm. This is glyphosate-resistant Canada fleabane on his farm. We added broad strike to Roundup and perfect control on Tom Hebblethwaite's farm. Really interesting to me, Chris Steele Farms, less than 15 kilometers away from Tom Hebblethwaite. We put on the exact same herbicide treatment, and it's a complete failure. And so the question is why? And so Tom Hebblethwaite has glyphosate resistant or Group 9 resistant Canada fleabane. Broad Strike's a Group 2, and it provides perfect control on his farm. In contrast to that, Chris Steele's the unlucky farmer. He has multiple herbicide Canada fleabane on his farm. It's resistant to the Group 2 and 9 herbicide, and it's a complete failure. And it's all based on whether you have glyphosate or multiple resistant biotype on your farm. Here we're going to look at the effect of chemical structure on herbicide performance. So this happens to be Doug Nelson's farm. He has water hemp on his farm, and I knew that on Doug Nelson's farm there was Group 2, 5, and 9 resistant water hemp. Atrazine's a Group 5 herbicide, so I expected atrazine to fail, and it did, right? And you can see that there was no control at all. What absolutely amazed me, this is Group 5 resistant water hemp, and we did a soybean experiment less than 100 meters away from where the corn experiment was, and we got perfect control of Group 5 resistant water hemp with a Group 5 herbicide, Sencor. And you look at that and you say, that makes no sense at all. And it all comes down to chemical structure. The mechanism of resistance is enhanced metabolism. So most of you had breakfast this morning. Your body uses enzymes to break down the food that you had for breakfast. Plants do the exact same thing with xenobiotics like herbicides, and they use enzymes to break down the herbicide. So in this resistant biotype, this plant has elevated levels of an enzyme called glutathione S-transferase. That enzyme binds to the chlorine on the atrazine molecule at the number 1 position. So it binds to the chlorine and it conjugates the herbicide with glutathione, which is a 3 amino acid polypeptide. That conjugated herbicide is recognized by ABC transporters. It's dumped into the vacuole and you have a resistant plant on your farm. And that's why there's no control with atrazine. Really interesting, Sencor doesn't have a chlorine at the number 1 position. It doesn't provide a binding site for that enzyme, and the herbicide remains active on that biotype. So now we'll talk about application timing. Too early with pre-plant herbicides, too late, or too late with post-emergence herbicides. So early pre-plant applications, and what I mean by that is on April 15 compared to early post on June 15 and no-till, provide lower weed control in mid-August because the pre-plant herbicide has been degraded more, and you have reduced late-season weed control in both no-till corn and soybean. Here's where soil-applied herbicide was applied too late, so almost just the opposite. This is research that was conducted by Jim Kells at Michigan State University. He applied dual pre-emergence to corn, 100% control of giant foxtail, 99% control when he applied it at the 2-leaf stage. And notice the decrease in control where he delayed the application to the 4-leaf stage. There was a 20% decrease in control because he applied the herbicide too late. And so there's reduced weed control with herbicides such as Dual Frontier, Zidua, and Prowl when applied after annual grass emergence. All of these labels will have a registration on the label that you can apply them post-emergence in corn. They're absolutely right, it's safe to do so. And when I taught the weed science course at Ridgetown campus, I always told my students, if you can see those annual grasses with the human eye, you better spray that day, because the weed control goes down really quickly once those annual grasses have emerged. In terms of too late, generally annual weeds are easier to control when they're young and actively growing. The cuticle is thinner and more permeable, and the plant is growing actively. And you have reduced control of large weeds with almost all post-emergence herbicides. including the Group 1 herbicides, Assure, Post, Select, and Venture, the post-contact broadleaf herbicides like Basgram, Blazer, Partner, and Reflex, the Group 27s like Armazon, Callisto, Lotus, and Shieldex, as well as glyphosate and Liberty. So here we're looking at the effect of the size of the weeds at the time of application. This happens to be research that was conducted by Brendan Metzger while he was a graduate student in my program. When Shieldex plus atrazine was applied, when the lady's thumb was up to 4 inches in height, it was 93% control. Notice the decrease in lady's thumb control as weed size gets bigger at the time of application. Where they're 8 inches in height, there was a 19% decrease in control. And where they're 12 inches in height, there was a 43% decrease in control. So the herbicide manufacturers are aware of that, and I took this statement straight off of the Reflex label. Syngenta says, apply Reflex when weeds are small and actively growing, and they go on to say later applications may result in poor weed control due to advanced weed height. And so in terms of application issues, you could have antagonism, the herbicide rate, failure to add the correct tank mix partner, the wrong adjuvant or time of day. So tank mixes with some herbicides will result in reduced weed control. Basgram antagonizes Post and Select, classic and first-rate yellow foxtail. Clay-based herbicide formulations, glyphosate, and some foliar fertilizers antagonize glyphosate. So I just got a 5-minute warning, and I'm not going to get through everything, so I'll go through that. Anyways, this is the impact of adding a foliar fertilizer to glyphosate. So if you look at glyphosate applied alone, it provided 100% control of green smartweed down to 76% control of lamb's quarters. Notice the red bar graphs where a foliar fertilizer was added to the tank. There is a decrease in green smartweed control of 6%, wild mustard of 13%, common ragweed of 33%, and a 58% decrease in control of lamb's quarters because of the addition of a foliar fertilizer. Where glyphosate was applied by itself, the corn yield was 171 bushels per acre, and there was a 48 bushel per acre yield loss from adding a foliar fertilizer due to reduced weed control. So in terms of herbicide rate, this is a different way to present a bar graph. So here we're looking at how much Roundup do you need to control control. And so notice that the blue line is 1 liter per acre. I think that's kind of the standard in Ontario. You need twice as much Roundup to kill a 12-inch lamb's quarters plant than a redroot pigweed. And you need 5 times as much Roundup to kill common ragweed compared to green foxtail. And not only do you need to know what weed species you have in each field, you have to adjust it based on weed height. And here you'll notice that you need 3 times as much Roundup to kill a 12-inch lamb's quarters plant compared to a 4-inch. In terms of the interaction between herbicide modes of action, this is Shieldex alone. It provided 34% control of fleabane, atrazine was 79%, and the combination was 94%. This is what it looked like in the field. The weedy check, atrazine unacceptable, Shieldex is unacceptable, and you add a reactive oxygen species generating herbicide, and you get perfect control. So in terms of adjuvant selection, man, have I ever learned to appreciate that weed control is influenced by which adjuvant you add. This is John Fluttert's work. He's looking at Shieldex plus atrazine. Here's where there's no adjuvant. He added Agril 90 and it improved to 64 to 95%. And notice where he added merge, there was a dramatic increase in control of 68% for ragweed, 42% for velvet leaf, and 48% with merge. This is what it looked like in the field. Here's where no herbicide was applied, Shieldex plus atrazine with no adjuvant, and here it is with the adjuvant merge. I can't stress enough how important it is to read the label and use the adjuvant on the label. In terms of time of day has been documented to affect the activity of some weed species, and research indicates that weed control with post-herbicides may be reduced when applied very early or very late in the day. Notice here, this is the control of 5 weed species, and notice the best control was at 3 o'clock in the afternoon, and there was a 32% decrease in control when sprayed at midnight. This is what it looked like in the field. Here's the weedy check. And notice at 12 noon, 3 o'clock, and 6, it's near perfect control. At 6 in the morning, you can't even see the ground between the rows because of the reduced control. And so that carried on to yield, and there was a 48 bushel per acre decrease in yield due to time of day of application. And finally, weed control is influenced by herbicide choice. What you have to remember is every herbicide has its strengths and weaknesses, and the secret for weed management practitioners is they have to know the weed species composition in each individual field, and then you want to match the herbicide to that weed species composition. So here you can see velvet leaf and ragweed escapes with Sencor. I don't want anybody in this room to leave that thinking that Peter Sikkema thinks Sencor is a poor herbicide. As a matter of fact, the use of Sencor is going up rapidly in Ontario. It's a great herbicide, but it's not good on velvet leaf and common ragweed, and you probably should have just chose a different herbicide for fields with those weed species. This happens to be research that was conducted by Clarence Swanton. Notice the near perfect control of wild mustard with first rate, and super disappointing on lamb's quarters. And once again, I'm not saying first rate's a bad herbicide. It just didn't match the weed spectrum in that particular field. And here you can see that eastern black nightshade escapes with Pinnacle. So just a few summary thoughts. The reality is weed control with herbicides is variable. I showed you lots of examples and reasons for that in my presentation. I will repeat what I said right at the beginning of my presentation. I think it is irresponsible for herbicide manufacturers, ag retailers, and agronomists to guarantee perfect weed control with herbicides. I also think that it's unreasonable for farmers to expect perfect weed control with herbicides in every field in every year. And even though weed management with herbicides is variable, I think they are incredible weed management tools. Farmers choose to use herbicides because it's their most cost-effective way to control weeds. If there was a cheaper way to control weeds, they would immediately go to it. And the return on investment in weed management is tremendous with herbicides. So thank you very much, and if you have any questions at all, I'd be most happy to try to address them. So really good question. The question was, in the trial where we looked at glyphosate plus a foliar fertilizer, it was an experimental foliar fertilizer blend from one of the companies. We had worked with that company previously with different foliar fertilizer blends. There was no antagonism at all, right? And then this specific one, it was obviously really antagonistic. And presumably there was lots of cations in it. Glyphosate forms a negatively charged anion in water. you have cations in the foliar fertilizer, they complex, and it's not taken up as efficiently. Well, thank you very much.